Hello, this is Tom Jarvis here to show you how to make a dynamic lapse formula. If you're an actuary, you'll probably need to do this at some point in the future. People do it in pricing, they do it in valuation, they do it in a lot of different modeling exercises. And what you'll find out today is building a dynamic formula doesn't have to be that hard. You don't have to rely on the default assumption that's built into your actuarial software. It may or may not work for your data. It's probably best to check and make sure your data fits something. And here's a way to develop a dynamic formula that you can be very confident works for you. Now we're going to start off here with my spreadsheet here. It's a spreadsheet that has a lot of tabs on the bottom. We're going to go to the data tab. Uh, what we're doing here is we're going to be pulling in data from an outside source. This might be administration system, it might be experience database. You're looking at that data right here. It's organized by month and age, policy duration, crediting rate. I'm taking those as kind of key items, and then I'm going to start summarizing the amount of data that I have at each one of these points. So you got a number of policies, account value, and surrenders, and so forth. When we're making our dynamic formula, we're going to be making it on two different things. One's going to be on policy duration. And by the way, my policy duration 0, like this particular policy right here, means that it's at the end of the surrender charge period is 0. Before that are negative numbers, after that are positive numbers, but that's just my little convention here for putting in policy duration. We're going to look at this here. We have crediting rates and we have competitor rates. Now, if our crediting rate is going to be bigger than our competitor rate, like this, it is here, we'd expect to have slightly less lapses than normal because, hey, we're giving out more than competitors, okay? Now, that competitor rate usually is something like, I don't know, you use the 7-year treasury plus 65 basis points. You can kind of go back and see how well that matches up with what your competitors are doing. But you need some type of assumption in here. In this case, it's being pulled from something like a Bloomberg machine, but you can always get historical data from one of those services like that here. I'm going to be taking the data here, which is the credited rate less the competitor rate, and I'm going to be grouping it because there's way too many values here, and I'm going to group it into 25 basis points brackets. I got a little table right over here that I'm using that's a lookup. If you look over here on the right side, it's going back and looking up to see where that difference lies, and it's going to put it into one of these groupings. Now, I chose 25 basis points. You might have enough data to do it every 10 basis points. I don't know. You're going to have to look and see how much data you have. 25 basis points seems to be working fairly well with this made-up example. I've also added one more calculated field onto this particular database here, and that is it reasonably close, the competitor and the creditor rates, to each other? So if they're within 25 basis points, I put a yes in there. If they're not within 25 basis points, then there's a no. And the reason for this here is that when I go to figure out my base rates, I'm only going to use the stuff that's going to be neutral, something where the competitor rate and the creditor rate are very close to each other. Okay, so we have all this data. I got about 23 lines of data. In reality, you might get 500,000 lines. Don't worry about it. I've used 500,000 lines in Excel. Seems to handle it very nicely. That was a few years ago when I've done that, but hey, Excel's getting faster. Computers are getting faster all the time. So with that, we got the database. Don't worry about these other columns. We're going to fill those in later. These last few computed items here. We're going to first figure out base rates. Well, the way we go about doing base rates here is we're going to use the stuff that is going to be close to neutral. That is, creditor and competitor, credited and competitor rates are very close to each other. So this is a pivot table, and we're going to use a filter, and we're going to put this through. Here's the results from the pivot table just showing up here. You got policies, account value, and surrenders. And surrenders by count, that's used for determining credibility. You can think about this in 3 different periods here. Surrender charge period. This is when the surrender charge exists, and the rates, generally the surrender rates are very low. We have a shock lapse period. call it shock, because as soon as that surrender charge goes away, you get all types of people surrendering their policies, and then we have the ultimate period where, hey, uh, there doesn't seem to be a clear pattern of what's going on. Now, I reorganized the data here. I'm going to be using 1,500 policies for full credibility. You can see what the credibility is right here. You got a little square root formula for figuring out that partial credibility. We compute the actual surrender value. I can show you what's going into that here. Gee, you're dividing two numbers. The math is not hard, 3.1% in that case. I'm going to get rid of those arrows. You can see the actual surrender rates right here. Now, it doesn't have a clear pattern. Usually what you want to do, because it's not necessarily very credible, is smooth it out. I'm smoothing it out by hand here. So I just put in these numbers by hand. When I put the numbers in by hand, I know a few things are going to happen here. One, I know that the surrender rate should be increasing over time, and that's because the surrender charges are decreasing over time. So I just put these into like quarter basis point or quarter percent. And when I do this, I'll go back and see, well, how do I match it up in total for the surrender charge period? So I have some summary statistics down here. And when I put in this particular set of rates, it does match up fairly nicely. Now, when I get to shock lapse period, hey, that's pretty credible. You got a lot of people surrendering there. It's 37.2%. So when I choose a rate for a base rate assumption for that duration, it's going to be very, very close to that 37.2. Got it coming through here. And then afterwards here, gee, these are all over the place. Some are high, some are low. I don't see a particular pattern. I'm just going to put in 10%, see how well that works. When I put in 10%, gee, I'm hitting that pretty much dead on for the ultimate period when I look at the summary statistics. So, you can get really fancy with some of this, or you can just try to do it by eyeballing it a little bit, and that's what's being done here. We're just eyeballing it, and we come up with a set of base lapse rates. So I'm going to go back to the data. We got our base lapse rates here. And on the data here, we put the base lapse rates in for each policy. We can figure out the base lapse rates for each one of these policies or these groupings over here. So I've added in two more formulas. Now, what we're going to need to do is make a dynamic formula here. So after I've done this here, and I got this for all 500,000 lines of my data, I'm going to go back and I'm going to look at the data. I'm going to go to places that says dynamic summary here. So we're doing another pivot table on all the data, and we have it grouped by the difference between the credited and the competitor rates right here. There's some grouping going on here. And you can see what's going on. Now, what you would expect here is that, you have the base surrenders here, and you have the real surrenders. Well, if we're going to be crediting a lot less than what's going on with the competitor, we're going to have a lot more surrenders. And that's what we're seeing here. This is just our normal surrenders if everything was neutral, but it's not. We're getting high surrenders. Kind of the opposite goes on the other hand. If we're crediting a lot more than competitors, nobody's going to lapse, and that's what's going on right here. I summarized in a little chart here. So this looks like this A to E ratio. We'd like to have an adjustment factor that looks like this A to E ratio, and that's what we're going to be trying to do. Well, we have to try to figure out a function that kind of looks like this right here. And graphing out this stuff is amazingly helpful. So I'm going to look at the graph on the next page. And when we look at the graph on the next page, gee, this looks kind of like an arctangent function. Okay? Or you can say it looks like a straight line with a max and a min. You can model different types of line. I'm using an arctangent formula here because I guess I want to be fancy here, but straight line with a max and a min might work very well here too. I'm mapping out the credibility. Where you have low credibilities, you're not getting the nice rates that you like, but hey, that's the way it is with low credibility. And so we're going to go ahead and try to construct a dynamic formula. And the dynamic formula is going to have an adjustment factor. It looks like this: 1 plus A times arctangent B times the difference between the competitor and the credited rates. And when I do this particular formula, I'm going to need factors A and B. I could put in factors like 0.5 and minus 350. And that would give us a adjustment factor that kind of looks like these A to E ratios. I always like doing the graphs. Okay, there's my adjustment factor formula. Here's what the actual to expected ratios look like. We'd like to have that line fit in with those little dots. It doesn't quite do it. And so we'd like to have a minimization technique going on here. Minimize, say, the square differences between these two items here. We got the square differences here. So what we'll do here is we'll use our solver stuff. So I'm going to go to the data tab, solver, and what solver does is it will figure out the optimal factors that will minimize some of the square differences. So we want to minimize I-40, which is this cell. We want to minimize it by changing these two cells, B16 and B17. And so I'll put in solve. Boom, there's the answer. I'll keep the solver solution. Let's see if it looks good. Darn tootin', it looks good. Look at that. It's fitting right on those dots. So you can use Excel to really come up with a very good formula that really fits the data very nicely. Excel does all that calculus for you. That's the nice thing here. Well, I wrote out the formula right here. Surrenders equal base rates times this adjustment for credited and competitor rates right here. That's what our formula looks like right now. I always like looking at graphs, and you'll see me doing this all the time. Let's look at it when we look at it by time. So we go back and we do a little quick pivot table, and we do the data by month. Hopefully get 100% on all these. Well, there are a lot of 100%s, but hey, that's kind of hard to tell if we got everything here. Well, I take that and I graph it out. Oh, there's some odd stuff going on here. Well, when you look at that, there's a spike in here, and you think, what the hell's going on? Excuse me, what the heck is going on? I'll try to avoid that bad language here. But what the heck is going on here? You got these high lapses. Well, it could be financial crisis, maybe. Maybe it could be that bad data. I don't know. Maybe at this point in time, your company had a replacement project here where you're trying to get people to move to a different product. Whatever the case, you have to go back and determine if you want another adjustment factor for this particular point in time. If it was for the financial crisis, you can figure out what type of factors indicate a financial crisis, put those and make another dynamic adjustment factor. Well, the other thing, when I look at this right here, it's got kind of declining rates over time. It's not right at 100%. It looks like it's slightly declining. That could be a sign of a lot of different things. With the aging population, maybe there needs to be another adjustment by age. Maybe you need something more for the ultimate period because you're getting more and more ultimate policies out here. It's a little hard for me to tell what the cause is, but you can start testing out ideas with additional adjustment factors. And that's the beauty of this method. You can start off with one adjustment factor, come up with others, and before you know it, you have a truly excellent formula. Well, that's it for now. I hope you enjoyed this. Write to me at dmxure at gmail.com. Be glad to talk to you about this stuff. Thank you for watching.